4. And PC3. 192.168.3.100. Then the mask. Gateway 192.168.3.254. The device is now configured. After, we need to configure the 3 routers separately. Open them all. Then, let's configure our 3. First, change the device name. Everyone should develop good habits. This is our 1. This is our 2. This is our 3. 3 devices. We configure the interconnection address for the interface. Our 3 is the address of the 2 interfaces. First, enter the interface. The interface does not need to return to the original view. Then you can directly from one interface to another. Everyone should know this. Secondly, let me tell you about the configuration format of the address. I made a simple mark here. There will be a basic configuration in the future. For example, on the left here is our 1. On the right here is our 2. Here is our 3. Then we will connect the directly connected network segment between device 1 and device 2, written as 12.1.1.x. Then point 1 is the device on the left. Point 2 is the device on the right. So this interface is 12.1.1.1. It is 12.1.1.2. For us, this is our 2. This is our 3. So what we write here is 23.1.1.2, 23.1.1.3. This serves as the interconnection address between them. Certainly, some students are more accustomed to writing 12.0.0.x. It's all okay. Choose a way you like. When we configure a lot of direct connections in the future, you can tell which equipment this is by looking at it. Okay. This is a brief introduction for you. Just pay attention later. We make a configuration. Here on our 1. We first enter the 0/0 interface. Configure an address. 12.1.1.1. 24-bit mask. Then enter the 0/1 interface. Configure a gateway. 192.168.1.254. Okay. Our 2 is the same. 0/0 interface is 12.1.1.2. And the mask. Then configure the gateway. This is the last device. This process won't last long. 23.1.1.3. 0/1 interface. We have now allocated addresses. Everyone must pay attention. All we have to do now is test the direct connection. Let's test it directly on 3 devices. Our 1 first pings 192.16.8.1.100. That is, ping PC1. See if it works. If it connects, there will be no problem between the 2 ends. Go to ping 12.1.1.2 again. See if it communicates with our 2. Also works. So let's finally test. Is our 2 connected to 192.168.2.100? Ping 23.1.1.3. Okay. Finally, R3 goes to ping 192.168.3.100. So we now do some basic testing. Ensure that there is no problem with the direct connection between each other. Next, we are about to start configuring static routing. Now let's read the title. What we want to do today is use static routing to make three PCs communicate with each other in pairs. The configuration format of a static route is: go to the destination network segment. Mask of the destination network segment. Add the IP address of the next hop. So now I ask you a question. I now want PC1 to be able to reach PC2. That is, I hope 1.100 and 2.100 will work. So let's analyze the process. PC1 is 1.0. PC2 is 2.0. Access across network segments. I will definitely find a gateway. Let's not talk about ARP requesting MAC. Find a gateway. Data here. The destination IP is 2.100. Query the routing table locally. It should not be in the routing table now. Let's check. Show IP route. Not in the routing table. Then the 1.0 network segment cannot go to the 2.0 network segment. So if I now from PC1 here go to ping 192.168.2.100, it sure doesn't work. So for now, it is destination host unreachable. There is no way to reach this device right now. It doesn't work. Now we are going to write a route. Let it pass. IP route 192.168.2.0 network segment. Assuming the mask is 24 bits. Then the next hop is 12.1.1.2. Check it out now. IP route. If under advanced command. If you want to check, you have to add a do in front. Otherwise return hashtag. That is the privileged mode. That's a little slow. So just do show. We can see here. The next hop to the 2.0 network segment is 192.1.1.2. Now there is a route. So can this data come over? Leaving aside the issue of data return. Okay. Able to. So let's recap. Looking for a gateway across network segments. Check your routing table. 1.100 to 2.100 if there is. The next hop is 12.1.1.2. But did not write out the interface. Route iteration locally. To find out which interface should be exited from. 12.1.1.2 local happens to go to 12.1.1.0 network segment. The outgoing interface is 00. I put this packet sent from the 00 interface. And the next hop points to 12.1.1.2. After it receives, this data goes to 2.100. 2.100 also has. Is the network segment of 2.0 directly connected to it? Because they are directly connected segments. So the data can come. Then you can't ping now. Request timed out. For us now. Packet sent out. But it is not possible to ping. Because the data passed. But when the data comes back, PC2 also received. PC2 also wants to reply